Hello, and welcome to Module 6.3, Solving Compound Inequalities. Our objective for today is first, that I can solve and graph linear inequalities containing the word and. Also, I can solve and graph linear inequalities containing the word or. So, when we look at this, a compound inequality is two or more inequalities that are connected by the words and or. An intersection is the overlapping section that represents an and compound inequality. A union is the graph of a compound inequality containing or, and the solution is a solution of either inequality, but not necessarily both. So with an intersection, with an or, it could be one or it could be both. In a compound inequality, in a and inequality, an intersection, it must satisfy both. So let's take a look at example A, and we'll graph this and we'll see how this plays out. So we have x plus 3 is less than or equal to 13. So we're going to start by subtracting 3 from both sides. We're going to get x is less than or equal to 10. Now on the other inequality, we're going to add 3 to both sides, and we're going to get x is greater than or equal to 2. So our rules for graphing these are the same as we did before. X is greater than 2, so we're going to have a closed dot at 2, and we are going to be shading it to the right. And now we're going to plot our second inequality, which was a closed dot at 10, and we are shading it to the left. And our overlapping section is going to be from 2 to 10. It's going to be where the two colors are overlapping. That is our solution set. So if we zoom in on it right here, our solution set is this part right here. That's our solution. All right, so let's look at letter B. Letter B is set up a little bit differently. We have one central portion and we have two outer portions. Now, this is a compound inequality, and there's two ways of thinking about this, right? We could think about this as -2 is less than x plus 2, and x plus 2 is less than or equal to 5. We could separate that into two pieces. I don't like doing that, though. I would prefer to us just solving this as one thing. So I'm trying to get x by itself. So I'm going to subtract 2 to get it away from the x. And I'm going to subtract it from all three portions of my compound inequality. So -2 minus 2 is -4. Is less than, we bring the x down, less than or equal to 5 minus 2 is 3. So now, when I have it set up like this, I look over at my graph, and now I have my upper and lower limits. I have an open dot at -4, and I know that x is greater than -4, so I'm shading to the right. So I'm going to go ahead and shade to the right from there. And I also know that I'm going to have a closed dot at +3, and I'm going to be shading to the left because x is less than or equal to 3. And so we move to the left, and hey, look, I used yellow and I used cyan, and I got a combined green. What on earth is going on there? That's a preview for the optics unit in science come February-ish. So my overlapping interval, though, is that portion that turned green. This is the overlapping part. That is my solution set for an and inequality. As you are graphing this, I need it to be very, very clear where your overlap is. So I strongly encourage you to use two different colors when you're doing your work, or use a pencil and a pen on paper. Some way so that I know definitively where my intervals are and where my overlap is. Now, letter C. Letter C, I'm looking at this and I'm trying to get all of my variables into one place. So I don't want them on the outsides. I want them on the inside. So I'm going to start by subtracting 2y from all three intervals. And I'm going to get negative 6 is less than or equal to 2y minus 8, which is less than or equal to negative 2. My next step, I'm now going to try to get that y by itself. So I'm going to add 8 to all three sides. And negative 6 plus 8 is 2. Is going to be less than or equal to 2y, which is less than or equal to negative 2 plus 8 is 6. And now my last step is to divide all three intervals by 2. And I get 1 is less than or equal to y, which is less than or equal to 3. So if we go to our graph, we have a closed dot at 1, we have a closed dot at 3, and we are going to be shading in between the two. So that is my overlapping interval right there. That's base right in between those. All right, I want you guys to try letters D, E, and F on your own, and then check your work against mine. Letter D. We are going to start by subtracting 5 from all three sections, and we're going to get negative 9 is less than x, which is less than or equal to negative 2. So we have an open dot at negative 9. We have a closed dot at negative 2. And we are shading in between the two values. Okay. Letter E. I'm going to start by subtracting 4 from all three segments. And we get 4 is less than or equal to 2w, which is less than 16. Okay, we're going to divide by 2 in all three portions. So we're going to get 2 is less than or equal to w, which is less than or equal to 8. So we have closed dots at 2 and 8, and we are shading in between those two closed dots. All right, lastly, letter F. We're going to start by adding 2 to all three intervals. And we get 6 is less than 2y, which is less than 12. And then we divide by 6. Nope. We divide by 2. 6 divided by 2 is 3, which is less than y, which is less than 6 divided by 2 is 6. So I have open dots at 3 and at 6, and we are shading in between. All right, so let's go on to our next page. We have an example of applying compound inequalities. So we have a cereal manufacturer distributes cases of cereal to grocery stores. Each case contains 12 boxes of cereal. In order to pass manufacturer's quality assurance test, the case must weigh between 336.4 ounces and 331.6 ounces, which includes 34 ounces for the weight of the case's cardboard box. How much does each box of cereal weigh? All right, so define a variable. How much does each box of cereal weigh? That's my variable. X equals weight of box. So I need to figure out my important points. And in this case, I'm going to be looking for what are my end values? What's my high amount? What's my low amount? So if it's going to be between 336.4 ounces and 331.6 ounces, that is my values. Okay. And so we're going to have 331.6 we always put the smaller value on the left and we put the larger value on the right. Why? Because that's the way the number lines are set up. Okay, and so we're always going to be less than and less than, or less than or equal to, less than or equal to. So this says that the case must weigh between 3.34 or 336.4 ounces and 331.6 ounces. Doesn't necessarily say that it can be equal to those values. So it's going to be just less than. And now we know we have 12 boxes of cereal per case. So 12x, and we have 34 ounces for the weight of the packaging itself. All right, so now we can go ahead and solve this. We're going to zoom in on it. We're going to subtract 34 from both sides. And when we do that, we get, let's see what, 297.6 is less than 12x, which is less than 302.4. And our final step is to divide by 12 in all three intervals. And I'm going to get 24.8 is going to be less than or equal to x, which is less than or equal to less than, which is going to be less than 25.2. So the boxes of cereal have to be between each individual box, 24.8 and 25.2. So what does this tell me? This tells me that the box is a 25-ounce box, and there's a margin of error of 0.2 ounces. And that way, your manufacturers, they want you to have as close to the exact amount as possible. They don't want to be over, but they don't want to be too far under where somebody's going to be upset with them and sue them over improper advertising. People aren't going to be super upset if you're over the amount that you're supposed to have, but the manufacturer doesn't want to have too much over because that's costing them money. All right, so why don't you guys try letter B on your own and then check your work against mine. So we have Keyshawn, and Keyshawn has been saving money to buy his first car. And he wants the total cost of the car and the fees to be more than $5,000, but at most $7,000. We've got the fees for buying a used car, such as title, registration, and dealership fees, are going to be $700. We want to write and solve an inequality to represent this scenario. So what is it that we're trying to find? He wants the total cost of the car and the fees. So what do we know? Well, we know the fees, so he wants to know the cost of the car. So X equals cost of car. Because you might have assumed that when you buy a car, the price you pay for the car is it. There are things that you need to pay in addition to the price of that car itself. So the title and the registration, these are documents that you are registering with the state of Illinois, right? You would have to pay dealership fees, so that's their advertising fees and things like that. So we want to know, we want the price to be more than 5,000, but at most 7,000. So more than 5,000, but at most 7,000. So we want it to be more than 5,000, so we're not going to be equal to 5,000. It doesn't say he wants it to be 5,000 or more. He said it wants to be more than 5,000. But at most, the highest value it could be is 7,000. So we have our variable, our x, because he is only buying one car. We're not multiplying it by anything. And we have these fees. So our dealership fees are $700. So that's plus 700. So now if we want to go about solving this, we're going to subtract that 700 from both sides of our inequality. Right? We're taking away the dealership fees from the values, like his range, and we're going to figure out exactly how much money does he have available to do what he wants to do. So 5,000 minus 700 is 4,300. is going to be less than x, which is less than or equal to 6,300. So the price of his car, the cost of his car, he wants it to be somewhere between $4,300 and $6,300. All right, example 3, solve and graph a union. So now we're going to be solving these OR inequalities. So this means we're going to have two separate inequalities that we're going to solve and we're going to graph. So we have negative 2y plus 7 is less than 1. So we're going to start by subtracting 7. And we get negative 2y is less than negative 6. Okay, and then we divide both sides by negative 2. And we get that y is going to be greater than, because we have to flip that inequality symbol, 3. So y is greater than 3. Okay, now our other one, we're going to do subtract 3 from both sides. We get 4y is less than or equal to negative 8. And then when we divide by 4, we get that y is less than or equal to negative 2. So we're going to do the green one first. We are greater than 3. So we have an open dot at 3, and we are greater than, so we're going to shade to the right. Our orange line. Y is less than or equal to negative 2. So that's a closed dot at negative 2. And we are going to be shading to the left because it's less than. So our solutions, it could be in one or of these sections, but it won't be able to be a solution for both because they're in opposite directions. All right. Letter B. Letter B. We have 2n minus 1 is less than negative 3. So we're going to start by adding 1 to both sides of our inequality. And we get 2n is less than negative 2. And then I'm going to go ahead and divide by 2. And we get n is less than negative 1. Our second inequality, we are going to subtract 2 from both sides. And we have negative 3n is less than negative 6. And we divide both sides by negative 3. We've got n is greater than positive 2. So we're going to go ahead and graph these. N is less than negative 1, so that's an open dot at negative 1. And we are shading to the left because it's less than. And we have n is greater than 2, so another open dot at 2, and we're shading to the right. Letter C. My first step on the solution on the left is to subtract 3 from both sides. And we get x over 2 is less than or equal to negative 3, in which I'm going to multiply both sides by 2. We get x is less than or equal to negative 6. Now we're going to add 1 to both sides on the second inequality, and we're going to get 3x is greater than or equal to 9. And then we divide both sides by 3. We get x is greater than or equal to 3. So we're going to have an a closed dot at negative 6. And we are going to shade to the left because it's x is less than or equal to negative 6. And we have an closed dot again at positive 3. And we are saying that we are greater than or equal to positive 3. And so we have that set up. Now, we are going to go ahead and do 3 U-try problems. There's 1 on this page and 2 on the next. So go ahead, try those, and we will check our answers against mine. All right, letter D, we're going to add 10 to both sides, and we get h is less than negative 5. Our second one, we're going to subtract 3 from both sides, and we're going to get that h is greater than negative 1. So we have h is greater than negative 1, so we have an open dot at negative 1, and h is greater than it, so we are going to shade to the right. We have h is less than negative 5, so it's an open dot, and we're going to shade to the left. Next page. We have 3n plus 11 is less than or equal to 14. So my first step is going to be subtract 11 from both sides. We get 3n is less than 3. Divide both sides by 3. N is less than 1. Now, on the right side, we have negative 3n is less than or equal to negative 12. So we divide by negative 3. We get that n is going to be greater than or equal to 4. So we have a closed dot at 4. And we are shading to the right because n is greater than or equal to 4. And our second one, n is less than 1, so it's an open dot at 1, and we're shading to the left. So letter F, we're going to subtract 2x from both sides. We get 2x is less than negative 10, and we divide by 2. X is less than negative 5. Our second inequality, we're going to subtract 3 from both sides. We have negative 3x is less than negative 15. And then we are going to divide both sides by negative 3. And we get x is greater than 5. So we'll have an open dot at 5. And we are going to shade to the right. And we are going to have a closed dot at negative 5. Nope, open dot at negative 5. And we are going to shade to the left. So now, example 4 is overlapping intervals. What are we going to do here? We have intervals that are overlapping. So let's take a look at it. We're going to solve, first of all, and we're going to do the same approach that we've been doing. So we're going to subtract 12, and I'm going to get 4x is going to be less than negative 10. And then we divide by 4. We're going to get x is less than negative 5 halves. Now, our next one, we are going to subtract 4 from both sides. We get negative 2x is greater than 0. And then we divide by negative 2. And we're going to get x is greater than 0. And when we divide by negative 2, we need to flip that to be less than 0. All right. So we're going to start with the green one. And it's going to be an open dot at negative 5 halves, which would be negative 2.5. So it'd be like right about there. And we're going to be shading to the left. Right? And now for our second one, x is less than 0, so that's an open dot at 0. And we're shading to the left again. So we're going to go this way. So in this case, anything less than 0 is going to be a solution because it can be one of the two of them. Anything that's less than negative 2.5 is going to be a solution to both of them, but it doesn't necessarily matter. I would like you to try letter B on your own and check your work against mine. All right, so 4m plus 7 is greater than or equal to 19. We're going to subtract 7 from both sides. And we get 4m is greater than or equal to 12. Divide by 4, m is greater than or equal to 3. Okay. Now, we are going to subtract 5 from both sides on the right. So we have negative m is less than or equal to negative 5. And then we are going to divide by negative 1. And we get m is greater than or equal to, because we flip our inequality symbol, 5. So I have a closed dot at 5. And we are shading to the right. And I'm going to have, and I'm going to do it in let's do it in purple. We have a closed dot at 3, and we are going to shade to the right. And look at that, we got that magic overlap again. This time with magenta and cyan, and we got blue. Interesting. Maybe file that away for when we get to our optics unit. All right, let's take a look at letters, the next section here, examples 5 and 6, which is writing a compound inequality for the graph. Now, if I'm looking at my graph here, I see the fact that I have an open dot at negative 2, I have a closed dot at 4, and I'm shading in between. So the way I'm going to write this, that is clearly an and inequality. So I'm going to write it this way. Right? We're going to focus in on it. We're going to have our higher limit, or our lower limit, negative 2, and we're going to have our upper limit, 4. And I know I have at least the less than symbols. So negative 2 is going to be less than because it's an open dot. 4 is less than or equal, the variable is less than or equal to 4 because it's a closed dot. And we put our variable in the middle. That's all we need to do for that one. Okay, so letter B. We have two intervals that are pointing in opposite directions. This means we're going to have two different inequalities. So the first one, the one on the left, x is going to be, we're going to the left, so that's going to be less than, it's a closed dot, so it's less than or equal to 8. Right? My second one, we have an open dot, and it's going to the right, so we're going to have x is greater than, and our value is 12. All right, there are two you try problems. I want you to do these two, and then check your work against mine. All right, so over here, we're shading to the left from 2, so we're going to have x is less than 2, and it's an open dot, so it's just less than. On the right, we have our variable, we have our value, we're going to be greater than, and it's a closed dot, so it's greater than or equal to. So x is less than 2, or x is greater than or equal to 3. All right, and you should specify the word or here. All right, our bottom one, letter D, we have an interval that's overlapping. So I have my lower limit, my upper limit. They are both open dots, so it's going to be less than and less than my variable in the middle. We don't need to include the word and because the way we're writing it here, it's showing that it's going to be an and. When it's a compound inequality and it's three pieces like this, we're saying x must satisfy both the upper and the lower limits in order for this inequality to be true. All right, that is the end of our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, have a great night.